Welcome to edupediaworld.com. You're watching the videos on quadrilaterals. So in this video we'll discuss the midpoint theorem, which is very important theorem from the exam point of view, and we'll also discuss the converse of midpoint theorem, so which is actually opposite of midpoint theorem, so how we can use it. Then we'll discuss some of the examples related to midpoint theorem, so how we can use the midpoint theorem and converse of midpoint theorem to solve the questions. So let's discuss the topic first. Now, the introduction we have, you have studied many properties of triangle as well as quadrilateral. Now let us study yet another result which is related to midpoint of sides of a triangle. Now let's say this is a triangle and these two are the midpoints E and F, and this line is parallel to this line, so this angle will be equal to this angle. So actually midpoint theorem says that if E and F are the midpoints, then we can say that EF is half of BC and EF is parallel to BC. Now let's discuss the midpoint theorem. So midpoint theorem says that if the line joining the midpoints of the two sides of a triangle, so we have two sides AB and AC, and these are the midpoints, and the line joining this midpoint will be half of the third side and it will be parallel to the third side. So this is a midpoint theorem. So let's discuss the theorems and how we can prove these theorems. Okay, now so first theorem is the line segment joining the midpoints of two sides of a triangle is parallel to the third side. Means, suppose these E and F, this point and this point, are the midpoints of the two sides of a triangle. So we need to prove that this line is parallel to this line. So let's see how we can prove this. First, we need to write given. So it's given E and F are the midpoints, right? Now, for construction, let's say we can extend the line EF to point D such that this line is parallel to this line. Okay, so we can say that CD is parallel to AB and BE. So CD is parallel to AB and BE. So for construction now, so let's discuss the proof. So for proof, consider triangle AEF and triangle CDF. So in this triangle we have this angle equals to this angle, so these are vertically opposite angles. So we can say that angle AFE equals to angle DFC. Why? Because they are vertically opposite angles. And we have AF equals to FC. Why? Because F is a midpoint of side AC, and we can say that this angle equals to this angle. Why? Because we can clearly see that these two lines are parallel. See, CD and AB are parallel and AC can be the transversal. So these angles are alternate angles. So we can say that angle EAF equals to angle DCF because they are alternate angles. And why they are alternate angles? Because CD is parallel to AB and AC is transversal, right? So we have three conditions. So we can say that triangle AEF is congruent to triangle CDF by ASA. Now, so we can say that now by CPCT EF is equals to FT. Now then we can say that also angle AEF we can say angle AEF means this angle is equals to this angle, right? Or we can say that angle AEF is equals to angle ABC. Okay, now why they are equal? Because these two lines are parallel. So let's see this how. Now we can say that EF equals to FD by CPCT. So we can say that now BCDE is a parallelogram, right? So why it's a parallelogram? So let's discuss first this. Now we have proved that triangle AEF is congruent to triangle CDF. So we can say that CD is equals to AE and CD is also parallel to AE, right? Why? Because by CPCT we can say, because these two triangles are congruent, and so we can say that also CD is also parallel to BE and CD is also equals to BE. Why? Because E is a midpoint. Now if one pair of opposite sides are equal and parallel, so it's a parallelogram. So we can say that these two BCD is a parallelogram. Now if this is a parallelogram, then we can say that ED is parallel to BC, right? So ED is also equals to BC then so we can say that ED can be written as half of, or we can say that it can be written as 2 times of EF. So we can write ED as 2 times of EF equals to BC, or we can say that EF is half of BC. So why ED can be written as 2 times of EF? Because F is a midpoint. So we can say that EF is half of BC and EF is parallel to BC. So this is how we can prove the theorem. So let's discuss the converse of this theorem now. So the theorem says that the line drawn to the midpoint of one side, let's say this is a midpoint and it's parallel to another side, so this line is parallel to this side, bisects the another side. Now we need to prove that F is a midpoint. So let's discuss what is given. It's given that E is midpoint and EF is parallel to BC, and so we need to prove F is a midpoint, or we can say AF equals to FC. We need to prove. So let's discuss the proof now. Consider triangle AEF and triangle DFC. So in this triangle we can say that this angle equals to this angle. Why? Because CD is parallel to BE by midpoint theorem, or it's given, it's an extension, we have drawn the construction, and we can say that this angle equals to this angle. Why? Because EF is parallel to BC, right? And so this angle equals to this angle and this angle equals to this angle. They are vertically opposite angles. So these two triangles are congruent by AAA or AAA. So let's write the proof first. Now you can say that angle EAF equals to angle DCF. Why? Because they are alternate angles. And then we have angle AFE equals to angle DFC. Why? Because they are vertically opposite angles. Then we have angle AEF equals to angle FDC. Again they are alternate angles. So we can say that triangle AEF is congruent to triangle DFC by AAA. So we can say that now AF equals to FC by CPCT. So we can say that now F is a midpoint. So this is how we can prove the converse of the midpoint theorems. So let's discuss some of the questions, some of the examples related to midpoint theorem and converse of midpoint theorem. So let's discuss the example number 1. Now example says that in triangle ABC, D, E and F are the midpoints of side AB, BC and CA. Now we need to show that this triangle ABC is divided into 4 congruent triangles by joining DEF. Means we need to prove that triangle let's say ADF is congruent to triangle DEF, and means this triangle is congruent to this triangle, and we need to prove that triangle DEF is congruent to triangle DBE. Then we need to prove that triangle DEF is congruent to triangle FCE, right? So means this triangle is congruent to this triangle and this triangle is congruent to this triangle. This triangle is congruent to this triangle. So let's see how we can prove this. Now if you see this properly, this is a quadrilateral. So let's consider first DEFC. Now in this, D and E are the midpoints and DE is parallel to AC. So we can say that then DE is half of AC, right? Since F is a midpoint, so we can say that DE equals to FC. So if in a quadrilateral, if one pair of opposite sides are equal and parallel, so it's a parallelogram then. So we can say that DEFC is a parallelogram. So why it's a parallelogram? Let's discuss again. Since D and E are the midpoints of the two sides of a triangle, so if the line joining the midpoints of a two sides of a triangle and is parallel to the third side, so it is also half of the third side. So we can say that DE is parallel to AC and DE is half of AC. So DE is equals to FC. So this forms a parallelogram. Now we know that diagonal in a parallelogram divides it into two congruent triangles. So we can say that triangle DEF is congruent to triangle EFC. Why? Because EF is a diagonal and diagonal in parallelogram divides into two congruent triangles, right? So, or else we can say that this angle equals to this angle, alternate angles, and this angle equals to this angle, opposite angles in a quadrilateral are equal. Or we can say that then this side equals to this side, so opposite sides are equal in parallelogram. So we can also prove these two triangles congruent by ASA rule. So anyhow we can say that these two triangles are congruent. Now again, if you see this properly, so this is also a parallelogram. Why it's a parallelogram? Again, E and F are the midpoints. If E and F are midpoints, so EF is also parallel to EB. So we can say that EF is half of AB, and since D is a midpoint, so we can say that EF is equals to BD since D is midpoint. So we can say that BD EBDFE is a parallelogram. So we can say that now the triangle BDE is congruent to triangle DEF. Why? Because BDE is a parallelogram and DE is a diagonal, and diagonal divides in a parallelogram into two congruent triangles. Now, so let's consider the last shape. So let's, if you can see this properly now, so this is also a parallelogram. Why it's a parallelogram? Again, D and E are the midpoints and DE is parallel to AC, so DE is also half of AC. So we can say that DEFA is a parallelogram and D and E are the midpoints, so D is parallel to AC and D is also half of AC. So we can say that D is equals to AF. So we can say that DEFA is a parallelogram. So we can say that now triangle DEF is congruent to triangle ADF. Why? Because again say we can say that DF is a diagonal and diagonal divides a parallelogram into two equal halves. So this is how we can prove these type of questions. So let's discuss the last example of this video, example number 2 now. So it's a very interesting example, so you have to watch this example carefully. Now it's given that L and N are the three parallel lines intersected by transversal P and Q such that L, M, N cut off equal intercept AB and BC on P. Show that LMN cut the equal intercept means we need to show that DE equals to EF. Now for construction we can join A and F so that it divides into two triangles. So if you can see that first triangle is ACF and second triangle is AFD. Now so first we need to write given. So it's given L, M and N are parallel lines and it's given AB equals to BC such that B is a midpoint. Now, so if you consider, if you can see the triangle or consider triangle ACF. So let's say this is a triangle ACF. In this B is a midpoint and this line is parallel to this line. Why? Because M is parallel to N, so it's given. So we can say by converse of midpoint theorem, so G is also a midpoint of AF. So this is how we can write. So we can write B is a midpoint and BG is parallel to CF. Why? Because it's given M is parallel to N, so it's given. So we can say that G is midpoint of AF by converse of midpoint theorem, right? So now we can say that AG equals to GF. Now if you consider this triangle AFD, means this is a triangle AFD, consider triangle AFD, G is a midpoint, right? And we can say that G is parallel to AD. Why? Because M is parallel to L. So we can say that E is also midpoint of DF. So why it's a midpoint of DF? We can say that by converse of midpoint theorem, right? So we can say that now DE equals to EF. So we can say that LMN, cut off the intercept, equal intercept DE EF on Q also. So this is how we can use the converse of midpoint theorem to solve these type of questions. So thank you once again for watching this video on edupediaworld.com. Keep watching further videos. Have a nice day.